set Bob's age to 21, Bob, name, and notice it's trying to be super helpful as I type. Notice that there's some other stuff in there that comes from a parent class, so I can choose age, name, or this other thing. Let's just do name, and his name will be quote unquote Bob. I did it again, so let's change that to this. And then lastly, let's go ahead and greet each of these. So let's greet Alice, and then down here, let's go ahead and greet Bob, and let's go ahead and define greet as follows. Greets the student via standard error. All right, so here we're going to go ahead and say avoid. Let's do greet student s, and then all this is going to do is a little debugging message, nslog, and then notice that it's trying to be helpful as to what I want to type next. So hello, comma, %, and it's not s. Take a guess as to what the placeholder is for an NS string object. %at. All right, so I see that you are %d years old, just to go back to our C roots here, comma, and then just as in C, name, s arrow, age, and that's it for the greet method. If I save, it's yelling at me here. What's it yelling at? Conflicting types for greet. Oh, interesting. Oh, OK. And that's simply another sort of C-style error. What do you need at the top of a file in C? The prototype. So we also need this here because we have to educate the compiler. Void greet student star s. Semicolon, save, scroll down, and hopefully, yes, it's happy again. All right, so let's try this. So now recall we created a class, student.h and .m resulted from that. Super simple, everything's public. Student.m had nothing in it, but we do need it because the class needs to be defined. In main.m, we're going to create Alice, give her an age and name, and greet her. Same deal with Bob, and hopefully greet will get called both of these times. So let me go up to the pretty little iTunes button, run. It's compiling, build succeeded, and sure enough, if I zoom in on the little debugger output, hello Alice, I see that you are 20 years old. Hello Bob, I see that you are 21 years old. Okay, so lots of room for improvement, right? What's one of the stupidest design decisions we made about a student? Right, it doesn't have anything in it, right? We're violating all of the fancy, nice little rules of thumb that we talked about earlier about encapsulation and data hiding and being able to validate data when you set it. So that was probably a cheat to just say everything is public and we're going to access it with the arrow notation only. So let's try now to improve upon this. But any questions on what we just did in this first example? Yeah? Oh, a prototype is just the return type, name, and arguments to a method, to a function that in C and Objective-C need to be stated at the very top of the file. So a C compiler, an Objective-C compiler, is kind of stupid in that you have to tell it in advance what functions exist. Otherwise, when it encounters the names of those functions, it won't know what to do. So because greet was defined at the bottom of my file, but it's used higher up in my file in main, I need to inform the compiler of it even higher up. Or what's a possible workaround to needing the prototype at all? Just move the function to the top of the file, which is a solution. It's not always possible, especially if you have circular references. But also, it's just nice, typically, I think, stylistically, to have main be the first thing in the file. So it jumps right out at you. All right, so let's go ahead and improve upon this one. Let me go ahead and define another command line tool, students2. Let me go ahead and hit enter, enter, and we're back at the point where we have a very simple starting point. And in version 2, let's at least introduce the notion of some setters or getters. Let's go ahead, actually, and pretend that I just followed all those steps. Let me go into lecture 4, students 2, and voila. We've just done what I said we would do. So here we have it in student.h. So this is almost identical. Notice that I did do this in advance, but I still have main.m, student.h, and student.m, and then all the other stuff, but I didn't touch any of the other stuff. We're only looking at 3 files at the moment. So in student.h, what's a little different? All right, so it looks like now I've done a few things that are different from before. One, inside of my student interface declaration, I still specify name and age, but for some reason I've prefixed them with underscores. Why might that be, if you have a hunch? Yeah. Yeah, so this is just a convention. When you anticipate variables being private, typically a convention in Objective-C, in Java, in other languages is to prefix them not with 2, but with 1 underscore, simply as a visual cue to you and any other developers working on the project that this is private. It's not something publicly accessible. It's just a useful trick. In the Windows world, you will very often use standard letters. Like in the Windows world, you'll say P for a variable name, a P foo, to indicate that foo is a pointer, and Microsoft has other similar conventions. Underscore typically connotes the idea of private. All right, so this is a little different, age and name. Now, what are these things called again? These 4 things collectively? Methods. So methods, and specifically, so instance methods. Instance methods meaning they can only be called once objects of type student exist, and the minus sign means exactly that. If they're instead class methods, it would be a plus. And if we actually looked at the code that someone wrote to implement an NS object in the .m and .h file for it, we would indeed see a plus for what method? Alloc, for the allocation method. All right, so these things we've seen before, albeit in the context of a slide, or we've seen things similar to this before. Age is the getter, set age is the setter. So whereas in the world of Java, it's common to say get foo and set foo, in the world of Objective-C, it's common to say foo and set foo. It's just a little cleaner, so you don't have to say the word get all over the place. So age is the getter, set age is the setter, and same deal here, name and set name. And notice that the data types are just different here for NS strings instead of ints, but realize they're returning pointers. So if you hated pointers in C, well, they are indeed back. This is not an abstraction we're going to be able to wave our hands at, as in Java. They're still there, but realize that it will be slightly less easy to crash your code as a result. All right, so that's it. And the only interesting thing to note, curly braces end up here. All of this stuff appears raw in the file, but before the @n sign. All right, and here's the .m file. So now we have the same thing before, at implementation and the import up top. So that means here comes our implementation, all of my methods. So how do I implement these? Syntax is pretty much the same. Just like in C, you copy and paste your prototypes and then remove the semicolon and start using curly braces. Same deal here. So minus int age is the getter. I'm just going to return underscore age. You don't need to, you shouldn't use this. Doesn't exist here. You simply mention the name of the variable, because when you're in the context of the object, the student object in question, underscore age refers to the instance variable. All right, same deal for name, return underscore name, and set age, we're going to do something very obvious. Underscore age gets age, and then down here we have name, underscore name gets name copy. That's actually kind of interesting. So we've not seen this yet. This is a message pass from a message called copy, the method, being passed to the object called name. And I say object because it's an object of what type? It's an NS object. It's an NS string. Why, in this case, do I want to copy the name and then store the result in underscore name, as opposed to just do underscore name gets name like I did up here? Yeah?
Is it because you're passing in like the address? So if, like, say later on somebody changed what's at that address to some other string?
Exactly.
Original.
Exactly. So this is the danger in pointers and in C also, is that if you're passing pointers around, if you just copy the pointer, you're literally copying the pointer to the same chunk of memory. Which means if someone else in the program, some other method, changes that person's name, you don't have the original name. You have now the resulting change, which maybe is what you want, but more likely, if you've got an object called student, the whole idea of encapsulation is that you store your own state, and it should be pretty independent of anyone else's functionality. So in this case, we indeed do want to copy the name string by passing it that method. And what it effectively does is returns a new pointer to the new chunk of memory that has identical copy of DAVID or whatever the student's name actually is. So that's the one distinction there. All right, any questions syntactically? All right, so now if we go back up to main.m, in this case, things don't change all that much in terms of allocation, but notice that the getter and setter are now being used. So the setters are being used here. Rather than just use the arrow notation, which you'll generally not use in Objective-C for reasons of encapsulation, now we're passing Alice the message set age :20 to set her age. The name is being passed as well there, and then we're greeting her. So we'll see how the greet method, greet function has changed. Bob is the same deal. And then if we scroll down here, notice that it's almost the same code in the nslog statement, but now I just say sname and sage instead of actually using the arrow notation. So in short, even though the syntax is kind of different, like none of these ideas are yet new, other than some of the jargon that we've been using versus PHP and even C. Any questions? All right, so let's start to clean this up. One of the most powerful things about Objective-C is that we can actually eliminate all of this stuff. Like this, we only have 4. But recall the story that we started with. If you have all these getters and setters, suppose we do add email, suppose we do add dormitory and phone number and the like. My God, we're going to have a dozen or more getters and setters in this file. And thankfully, and one thing Java does not have to the same extent,